So Z1 and Z2 be two new observations. If the prior probabilities for P1 and P2 are assumed to be equal and the misclassification costs are also assumed to be equal, then according to the linear discriminant rule. So first of all, like we have like two bivariate normal populations. So population 1 is having mu1 as 0, 0, whereas population 2 is having mu2 as 1 and 1. And they are having like common covariance matrix which is 1, 0.5, 0.5 and 1. So they are having equal priors and equal misclassification costs. And we were given two observations, 0.75, 0.75. And Z2 is also given as 0.25 and 0.25. So the linear discriminant rule, so LD rule for equal priors, so that is nothing but, so we assign this Z to P1 if Z minus mu1 plus mu2 by 2 whole transpose sigma inverse mu2 minus mu1 is less than 0. Otherwise, we assign it to this P2. So by using this, so if we find like, so mu2 minus mu1, so from the given thing, so I can find mu2 minus mu1 which is 1 comma 1, and I also have mu1 plus mu2 by 2 which is 0.5 and 0.5, and sigma inverse also I can find, so which is 1 by 1 minus 0.25 into 1 1 minus 0.5 minus 0.5. So that means this is nothing but 4 by 3 into 1 minus 0.5 minus 0.5 and 1. So that means sigma inverse mu1 minus mu2 will just be 4 over 3 into 0.5 and 0.5. So that is nothing but 2 by 3 and 2 by 3. So therefore, if I find like Z1 minus mu1 plus mu2 by 2, so that is nothing but 0.25 and 0.25. So if I multiply these two, so 0.25, 0.25 and 2 by 3, 2 by 3. So we can clearly see that it is nothing but 1 by 3, which is greater than 0. So that means Z1 belongs to population 2. And similarly Z2. So Z2 minus mu1 plus mu2 by 2. So that is nothing but minus 0.25 and minus 0.25. So if I multiply minus 0.25 minus 0.25 with, minus 0.25 minus 0.25, if I multiply with 2 by 3 and 2 by 3, so this will give me minus 1 by 3, which is less than 0. So therefore Z2 belongs to P1. So Z1 belongs to P2 and Z2 belongs to P1. So option B is the correct answer.